Hi, this is Mrs. Hunt, 5th grade teacher at Stout Field Elementary, and we're here with Mr. Crosslin today, learning all about the layered atmosphere.
Hey, thanks for that introduction. Today's lesson is going to be kind of fun. I mean, I love it. I hope we're going to learn some new things that are kind of hard to understand, but they've been all around us all the time. In fact, it's the atmosphere. We're going to be studying the atmosphere, and our atmosphere is different than a lot of atmospheres. The atmosphere is, and you might want to draw a small picture right here. An atmosphere is, if we have a planet, let's say we have like our planet Earth, it has an atmosphere. And the atmosphere is not the solid part of the Earth, but the atmosphere is actually a thin, now this is where it gets confusing for me. I'm going to tell you the atmosphere is a thin layer of gases and liquid with water vapor that surrounds the planet. And then I'm going to turn around and say, the atmosphere is really thick. So what is it, thin or thick? Well, it has to do with relativity. It's thin compared to something, thick compared to something else. Have I confused you yet?
No.
Oh, good. So here's the Earth, and let's put the atmosphere on the outside of it, okay? There's our atmosphere. And if we had to say what is an atmosphere, we might say an atmosphere is the gas and vapor that surrounds a planet. Now, Earth's atmosphere is mostly made up of, what do you think? You ever heard of this? What's in the Earth's atmosphere? Everybody take a deep breath. What's in it?
Air.
Air, and it's good for us, right? We can live with it, right? Most of it is 70% something you probably don't even know, nitrogen, and about 29% oxygen, O2. And that leaves some other stuff that's in there. But every planet has a different atmosphere, and some objects don't even have an atmosphere. For example, Mars. Mars is like our sister planet, Mars. That atmosphere there is even thinner than the Earth, and it's mostly CO2, carbon dioxide. It is so thin that when we go to Mars, we're going to have a hard time landing there. You know, an airplane can fly through our atmosphere because it's made of air, and air takes up space and has mass. But Mars, it's so thin, man, can you imagine this? If we jumped out of an airplane on Earth with a parachute, and down we would float. On Mars, the air is so thin, if you jumped out of an airplane on Mars, if you could, with a parachute, you would fall a lot faster because the air is so thin, it's hard to catch you. So we're going to study the Earth's atmosphere, and we're going to find out that it's actually layered. So I told you the atmosphere is thin, but it's also thick. All right, let's start with the Earth. And so I'm going to make it, this is not to scale, by the way, but let's put the Earth down here. This is not to scale, but I'm going to make it round a little bit. And we have different layers. If I put a line coming up here, all the way up, and let's go about 50 miles up here. And around 50 miles is kind of the end of our atmosphere. There's a name for that. Stuff that's outside of our atmosphere kind of reminds me, what do you call that covering that's on like a spider or insect? It's called exoskeleton, right? That means outside. And so up here we have something called the exosphere. Exosphere. That means things outside of the atmosphere. So that's way up there. And then we have one down here called the
Biosphere.
The biosphere. I like that. The whole thing is called biosphere, but this is what we're going to call this the troposphere. In fact, we're not going to, but it's called the troposphere. And that's where we are right now. Everybody take a deep breath of the troposphere. Thanks. Now it goes up in the sky, but I'm going to tell you the mountains are not as high as a troposphere. Mountains, city, people, airplanes don't go all the way to the troposphere because it's too high to go. So the troposphere includes the air we breathe and where the mountains are and where airplanes go. Next, we have something called the stratosphere. Stratus with a U, stratosphere. We don't want to go in the stratosphere. It gets colder as we go up, and it gets thinner. The air's, you couldn't even breathe right here. In fact, we like to call this, well, I don't know if we like to call it, but right about here is the death zone. I'm going to write DZ, death zone. Anything above this, there's not enough air for us to live. You ever seen pictures of people climbing mountains?
Yes.
And most mountains aren't tall, but if you go to some of the highest mountains in the world, like the Himalaya Mountains, Mount Everest, and we'll take a picture of that just to look at that in a second, you get to a point where the air is so thin and it's so cold that you would die within minutes unless you bring oxygen and warm insulating clothes. Up here, forget about it. You won't make it. We have further to go. In fact, a spaceship, yeah, we'll talk about that. So now we have the meso. It kind of reminds me of middle. Mesosphere. We're going higher and higher. And finally, we have the thermo. It has like thermosphere in it. Now there's other parts like the ionosphere, but we're going to talk mostly about these different layers of the Earth's atmosphere. And it's kind of cool. From here all the way up. Let me give you a chance to get caught up. Okay, so remember I told you how the atmosphere was thin and thick at the same time?
Yes.
Well, 50 miles is pretty thick, but when you think of the whole Earth, it's really thin, which means we should really take care of the atmosphere because things that burn or smoke or pollution that get up in the air or chemicals that we use sometimes, those things stay in the atmosphere and can affect the atmosphere. So let's take, you know what this is, right? What's this?
An apple.
An apple. And an apple has, the middle of the apple is called the core. Guess what? The Earth, the middle of the Earth is called the core. So this is an analogy. I'm going to compare the Earth and mostly the Earth's atmosphere to this apple. You understand that? All right. So let's cut through the center of the Earth. And if I do that, cut all the way through it, we should have two hemispheres, right? Now, see that right there? I want you to check it out. See that? The core, the mantle, and the crust. The atmosphere on our Earth is thinner than the skin of that apple compared to the rest of the Earth. You know what I'm saying by that? So really, we live on the crust, but the atmosphere is as thin as that piece of apple right there. So what I'm saying by this is that we got a lot of things on the Earth we can do. We can dig, we can mine, we need to do so many things here. But we really need to take care of our atmosphere because this is the only place I know of in the entire solar system or so far in the galaxy where we can do this. And breathe the atmosphere. So our atmosphere is very thin. We really need to take care of it. Okay, so things that move through the atmosphere, since the atmosphere is made up of air, and air is made of matter, it's stuff, right?
Yeah.
It's not a liquid, it's not a solid, it's a gas. But it takes up space and has mass. What that means is, piled from here all the way into space, we have air pressing on us all the time. And guess what that air press is called? Air pressure. So when things move through the air, when it's really thin, not much is happening. But when they move through thick air, well, let's try an experiment. Take your fingers and go like this. Here's something rubbing through air way up in the thermosphere. You feel much? No. It's just like do it a couple times. It's like a rock, or not even a rock. Time out. Here is a chunk of metal from outer space. That really is from outer space. And here's a chunk of rock from outer space. This was traveling thousands and thousands of miles per hour from outer space. It's called a meteorite. Now, when it was up high, it was just going like this. Nothing was happening. But then it got thicker. 2 fingers. And then it got even thicker down into the mesosphere. And when it got in the mesosphere, it's going so fast. And rub your hands. What do you feel now? What do you feel? Heat. Stop, stop, stop. If you were going 17,000 miles an hour, your hands would catch fire. And that's what happened to this piece of metal here. You can see how it's melted. Check that out. And that is actually a melted piece of meteorite that was going thousands of miles an hour. It didn't start to get hot up in the thermosphere. It didn't get hot in the mesosphere, but it started to in the stratosphere, and by the time it hit the thermosphere, it was on fire. Let's take a close-up of these three meteorites. They actually have gone through from exosphere, outer space. Here's a stony one that ended up landing in Arizona. Here's a glassy one that landed in Czechoslovakia, and this is a metal one that I got from a science convention. All three of these meteorites have come millions of miles through all the layers of the atmosphere and landed here on Earth. Pretty cool stuff. Okay, you know, besides rocks coming from outer space, sometimes we start here and go to space. And maybe you know what this is, right? This is it's a rocket ship. It's called the Space Shuttle, right? And the Space Shuttle starts on the Earth, right? 3, 2, 1, up it goes, up through the troposphere. As the Space Shuttle went higher up in the troposphere, all the fuel in the solid rocket boosters would be used up. Now this is interesting. You might say, Mr. Crosslin, to have a rocket, you need fuel, heat, and oxygen. But the higher you get, the less oxygen. So you know what you have to do? You have to bring your own oxygen. Oxygen is mixed into this fuel. So as it goes up through the troposphere, it's burning all the fuel and the oxygen inside of here. These are done. These are done. They parachute back through the troposphere. Now we're going higher into the stratosphere. And the shuttle will spin around. This is filled with oxygen and hydrogen. And it's shooting into these engines down here. So once again, it's so thin up there that they have to bring their own oxygen or there won't be any fire. That's why an airplane can't fly that high. An airplane flies high, its engines go out unless it brings its own oxygen. Up goes the shuttle. It's almost in the mesosphere, and this is empty. And this is made to spin, and it spins so much that it gets hotter and hotter, like your hands rubbing together. What's that force called when you rub your hands together, they get hot? It's called what? Friction. So this crashes and burns up, and now it's time to be in space. Going through that air so fast, it is really, really hot because of friction and the engines. So it opens up the payload bay doors, cools off. Now it's going through space, and it can go sideways, it can go backwards, upside down. It doesn't matter. You know why? There's no air up there to get in its way.
And there's no gravity.
There is gravity. There's always gravity. There's gravity, otherwise it will slow down. But there's no air because it's in the exosphere, right? It's about 100 miles up, and now it's time to come back to Earth. They fire their rocket, they have some fuel left, and they start coming down. Now, if they went straight down, they would go too fast.
And they'll die.
They would go too fast. But no, what they do is they need to go like this, like make a big S curve. And when they put more of that shuttle towards the air, it starts to slow down. See what I mean? You ever put your hand by the window when you're driving the car? This way is smooth. This way, you feel the difference? Same thing. When it goes like that, it's the air is piling up and slowing down. But there's a problem, my friend. When there's more air and going faster and faster, guess what's happening to the space shuttle?
It's falling
Less
apart.
oxygen?
No, inside they're fine, but what's happening to the outside as it
It's
goes?
falling apart.
Rub your hands. What happens to it? It gets so hot that it would actually burn up. The air catches fire. And so this is an actual space shuttle tile. This is the tile that's on the bottom of the space shuttle. In fact, a nickname for the space shuttle was the Flying Brickyard because it had all these tiles on it. Now this tile is a special ceramic. So you could put 1,000 degrees here and it's going to be cool on this side. And that's because it's covered with all these, and as it comes back, the air goes across this. Rub that 17,000 miles an hour. No, don't. Your hands will catch fire. But what would So what is that force again that as it goes through the air? Friction. And the closer to the Earth, the thicker the air. So up here, a little bit of air, more air. As we get closer, full atmospheric pressure. And that's why we need this to protect this from the lower atmosphere. Okay, so let's go back to our drawing. Let me explain this air one more time. And before we make our layered atmosphere, I want to do two more experiments. So like, what if we had a giant plastic box, okay? This plastic box was only 1 inch square. You got that? Yes, yes? This is not the scale. But here's a box that's 1 inch by 1 inch. It's a square inch. Got it? Now, if we look at the air molecules in here, where do you think they're going to be thick? At the top or the bottom? Where is the air going to be piled up? At the top or the bottom? Bottom. In fact, up here, you won't see any molecules. You might see one, a couple molecules, right? Not many. But here, it's starting to get thicker, right? And here, thicker. In fact, the farther we go down, guess what? Yeah, I like to hear that. I hear those molecules piling up and piling up until down here, whoa, we have a big pile up of, and stop. So here's our air pressure. The air pressure gets thick down here. This is more, right? You got that? And this is less. Do you understand that? Minus and plus. Because it's all piled up here. Do you understand that? Do you know that right now we walk around in the troposphere and we have all of that air pressing down on us? Come here, I need a volunteer. Thanks for volunteering. You know how much air is on top of us? A lot. 50 pounds up. This is a atmosphere bar. This bar weighs 14.7 pounds. Put your hand out. In fact, if we took all the air from here all the way up, from sea level all the way up to outer space, this is how much air. Feel it? How's it feel?
Heavy.
Pretty heavy. This is much air is on you, not just on your hand. I won't hurt you on this, but it's also on your chest, on your chin, on your head. It's pressing all around you. 14 pounds, 14.7 pounds per square inch. See how that's a square inch right there? Here, go ahead and pick that up. And do you realize that you walk around with that on you all day long? No? You didn't know that. So I'll let you guys feel this thing here in a little bit. But you know what? We can try another experiment because this air, you may not even think it, you can feel it.
Here I have a piece of wood and a newspaper. Which one of these is heavier, boys and girls?
Wood.
Okay, and why is the wood heavier?
Because it has more density.
Okay, so what I'm going to do is a little experiment. And I'm going to take this hammer and I'm going to hit the piece of wood. And we're going to see what happens, okay? Are you ready?
I'd hit it really hard. You mean it's going to fly up? Isn't the newspaper going to fly up in the air, kids?
Yeah, the newspaper's just going to fly up, right?
Or what else could happen?
It could break or rip.
What's going to hold the newspaper down?
Air.
The atmosphere. Well, let's see if the atmosphere really will hold it down. Here we go.
Both of you, back up. Ready?
Wood fly. John Cena.
Hard. I think you missed the newspaper and hit the desk.
Well, Mr. Crosslin broke off.
It did? Then I'm wrong.
it broke off.
We'll have to check slow motion. Oh, look at that. Hold out your hand. But it didn't tear up the newspaper.
The paper barely moved.
Let's do that again. Wow. See how it broke that and didn't even push it? There you go. Look, we're at 16 and 17. Let me get a close-up of this. And you're telling me that that newspaper is going to stay? Here we go.
Watch the paper. Oops. I did hit the desk that time. Uh-oh.
Not my desk. Wow. It went from 16 to 14. And hold on your hand, let's see here.
It's right here.
We have success. We have success. The atmosphere is stronger than Mrs. Hunt with a hammer. Don't mess with either one of them. Let's try one more time. Okay, I have Andrew here. We're going to demonstrate something else. Remember I told you walk around the troposphere with all this air around you, you don't feel it? Well, I have a bag here, big old bag. And step over that way just a little bit. There we go. A little more. Okay. And what we're going to try to do, Andrew, is we're going to try to suck all the air out of this bag and see how you feel. How you doing in there? You doing okay? Can you move your arms all right? Move your arms okay? Well, see, this is still normal atmosphere. But I don't want to use the word suck the air out. We're not doing that. We're going to remove the air, and the atmosphere is going to force it against him. And you'll have a hard time moving your arms. Okay? Here we go. Are you ready? Yes. Any last words?
No.
Have insurance?
No.
Oh, too bad. Here we go. We should see let the air go. It's going to suck out. There we go. Keep moving it. There we go. Notice anything yet? Get it unclogged. Unclog it. There we go.
Oh my God!
Notice anything different? Unclog it. We've got all the air out. Now try moving your arms. It's harder. The sky is pushing down on it. Can you turn around? Let's see. All the way around. Turn back around. Move this arm out. Hard to do, huh? This is what it's like when the whole sky is pushing over you. Let's let the atmosphere come back in so at least you can take a breath. How did that feel? How did that feel? Bad? You know, it was like you had like 3 people piled on top of you. Just to show you what I mean, I don't like to call this a dog pile. I like to call it the layered atmosphere. Andrew, lay down on that. Okay, how do you feel, okay? Not much is pushing down on you. Who's next? Come here. Lay over him, Donovan. Just easy. Yeah. Now this is what it's like. How you feeling down there? Talk to us. Next one. Now how do you feel? Look up at the camera. And that's what's happened when we make a layered atmosphere out of boys in the 6th grade. I had and made a model of the Earth's atmosphere, and you're going to make one too. Here's my model. I have a marble on the bottom that represents Earth. Then I have corn syrup, which is very, very dense. It has sunk all the way to the bottom. And that will be our troposphere. Next, stratosphere, made with syrup. And then the mesosphere, made with water, and it's not as dense. And finally, the thermosphere, I made with cooking oil. And then up here, we have the exosphere. In fact, this is so cool. These are different densities. Just like the Earth's atmosphere, things are thick at the bottom and thin at the top. Now this stuff we're going to use here is corn syrup, brown syrup, colored water, and cooking oil. I just want to show you what's going to happen if I put, now this is kind of sticky because it's dense. What do you think is going to happen if I put a drop of dense liquid here? What do you think is going to happen?
It's going to stay at the top.
It could stay at the top. What else could it do?
I think it's going to sink down to the bottom.
Let's find out. Let's put a little bit in here and see what happens. There's a glob of it. Oh, it went, I didn't even see it. Oh, went through the blue. Oh, where'd it go?
To the brown.
It stopped in the brown, and I bet
It's going down and then back.
it's going down.
It's going down.
Oh, it's starting to, and I bet it will sink right.
It went back up.
I think that's air coming up. Well, what happens if we put blue water in? Where is it going to go?
To the blue. It's just going to stay.
Is it going to stay? Well, let's find out.
It's going to down.
And it went and stayed at the blue. Well, let's see. One more drop in there. Cool. All right. So things will mix. In fact, someone asked me what happens if I turn this whole thing upside down. What do you think would happen?
Oh, switch ways. Switch.
It might-
I think it would go back. I think it might just spill.
Here's what you're going to do. Let's put this aside. At your desk, you have a cylinder, layered atmosphere of the Earth. And we're going to start by, on the tray, you have a small rock. It's the third rock from the sun, Earth. Drop the Earth in there. Here's our model Earth. What's the next layer? Corn syrup, or we like to call that the troposphere, right? Before you put that, take your clay, and what I want to do is we're going to make a little stand for this, all right? Yes, yes, understand? Yes, yes?
Yes.
Now this is, you're going to have to be careful with these pipettes, don't mix them. And I'm going to put, see how I'm doing this right over the top, so it doesn't spill down the side, I hope. And here we go. And here comes the troposphere. Everybody say it.
Troposphere.
That's where we live. It's thick, it's dense. We want to keep it clean. And there's the troposphere. I think that's enough. Okay? And you see it start to come up? What's next? After troposphere?
Syrup.
Yeah, but what layer?
Syrup stands for
Stratosphere. Now this is not as thick, and so it's less dense.
Very sticky.
And it does not mix so much, but here we go. I can't help it. And I made a little bit of a mess, but look. Is that cool or what?
It's mixing.
It is mixing?
No.
A little bit.
It is?
No.
I see one layer and another layer. Is it mixing to you?
No.
No, use your eyes, you let me know. I don't know.
I don't
All right. After the stratosphere, we have troposphere, stratosphere, troposphere, stratosphere. In the mesosphere, we're going to use blue water because it's less dense. Ready? Here we go. Cool, doesn't mix.
It's layers.
It's layered. And what does that leave, our last layer?
Cooking oil.
No, not cooking oil.
Cooking oil.
Thermosphere. It is cooking oil, but you know, come on. And then, and what's at the very top? Exosphere. And so there, my friend, is our layered atmosphere. There's the Earth down the bottom, troposphere, stratosphere, mesosphere, exosphere, and up above, thermosphere and up above, exosphere. Now, don't be the kid who spills this. Don't be the kid who spills it on their Chromebook. And don't be the kid who takes it open and spills it on the bus, okay? Don't be that kid. Be the kid who makes a layered atmosphere and learns about a little more about our Earth. What do you think is going to happen if I turn this upside down?
Change colors.
Let's find out. Ready? Should we try it?
Yeah.
It's not going to stay the same.
I switched places.
Swap places? Okay.
They swap.
I'm done.
They're starting to mix, but look what's happening.
It's rising.
It's rising.
The oil's going up, and guess what's coming down?
Syrup.
The syrup. That's pretty cool. Would you guys like to try this?
Yes.
Well, let's go back to our seats and get started. Go ahead, get started. Got your clay, got your rock. Start with the syrup, the corn syrup. Get close to it.
Is this the corn syrup or that one?
That one.
See how I move my model up? There you go.
I need it. Now, guys. Here, give me that. Dylan, please. This? Yeah. Thank you.
I need it.
It's sticking. I thought I was doing. You're gonna drop it. I'm so sorry, Tiny Eric.
Wait, what?
This needs to be on here. Can you see that, Karita? Wait, patiently.
You too.
You're supposed to squeeze it down.
Slowly. See how it shoots down there? But look, it came back up.
We just can.
Wow, that's so cool. Can you explain, can you name all the layers? What's the bottom one?
Troposphere.
Yep, and then the
The atmosphere, but it's
Stratosphere.
point to the troposphere,
Troposphere.
and then stratosphere. What's next? The blue one?
Mesosphere.
Yeah, and the next one?
Thermosphere.
And finally, outside,
50 miles.
50 miles up is the exosphere.
Exosphere.
So cool. Go ahead and put your cap on. Our first guy's done right here.
Oh,
Our-
wow. Good job, Pickle.
Atmospheric scientist at work. Well, as you can see, that these kids are on cloud 9. Ha ha ha. Good job, guys. Hey, what's today's lesson called? The layered atmosphere. Good job.
okay. Thank you.
Mr. Crosslin. The layered atmosphere.
What?